Hello children, welcome to channel Sube. Children, today I am going to discuss question number 38 from the MCQ part of 2021 Physics New Syllabus paper. A flywheel of moment of inertia 0.4 kilogram meter squared is rotated with uniform angular speed of 10 radian per second by a motor of power 100 watt. When the motor is switched off, the angular deceleration of the flywheel is 1, 20, 25, 200, 400. So children, you must have learnt the linear motion before rotational motion. In that lesson you must have learned this equation, P equals Fv. Here the P is power. P is power. P is power. F is the force, especially it is the friction. F is friction. V is the velocity. Now this problem is about rotational motion. So we have to convert this equation to the suitable rotational motion equation. So how we do? P is same. P equals, instead of F we have to write tau. Instead of V we have to write omega. P equals tau omega. This is the equation that we use in rotational motion. You don't have to derive this, just you have to convert these symbols like this. So you can use this thing, and because P they have given 100 watt, so let us substitute 100 watt equals, we don't know tau. Before you find this angular deceleration, you have to find out the value of tau. Tau is the friction. So we don't know tau, therefore we write it as it is. Then omega is given, angular speed is 10. So when we simplify this, 100 divided by 10 is 10. So we get tau as 10. What are the units? Newton per meter. Newton per meter, because tau is what? Tau is the force times the distance, force time the distance d. So it is rotating around this point, so tau is F times d. That you don't want here, but just I recalled your memory. If we happen to use it, then you can use it, but here you don't want that equation. Then we need the other equation, tau equals I alpha. Tau equals I alpha. This is the second equation we need. So you should remember these equations. This also we get from the linear motion equation, that F equals ma, you know. So instead of F we write tau. Here also we did that the same thing. Instead of F we write tau. Instead of m we write moment of inertia I. Instead of acceleration, simple a, we write alpha, angular acceleration or deceleration. So that way you get this equation. You don't have to derive these things. Then we know tau. Let us substitute tau is 10 equals I also given in the question 0.4, 0.4. So we don't know the deceleration. So deceleration is 100 divided by 4, that is equal to 25. Why we say deceleration? I said at the beginning itself that this one is the friction. So this one also then friction. Therefore this alpha you get is a negative value. This tau is negative here, since this one is the friction. Tau is negative, and here when that negative sign comes to this place, this one also get this negative sign. So this is deceleration. So the answer is, children, 25, this one. So let us check it. Question number 38. The third one is the answer. So that is how we have to solve this problem. So children, I think you can understand this. This is not a big issue. Only two equations you have to use. So let us do some exercise today, because we have a lot of time. Therefore let us do some exercise. I will give you some exercise in this nature, several problems in this nature, same as this, only the numbers are changed, so you can practice it, then you can remember these equations. When you use these equations, then only you can keep them in your mind, otherwise forgetting is it is normal. So children, I have prepared some exercises for you. These problems are the same, but only I have changed these values, so you can practice those two equations, then you will not forget it. So there are 11 problems, so you can take a snapshot, screenshot of these problems after pausing the video. So now take a screenshot. Now take a screenshot. So I am scrolling. I am going to scroll now. After 6, 7, 8, 9, 10, 11. Take a screenshot of these questions also. And now I am going to scroll and take a screenshot of these answers also. You have to check only these two columns. First you find the tongue and checking the question number is here, and the final answer, angular deceleration, is this one. So only these two columns you have to check. These are the data, inertia, power and angular speed. So this data is there in the question, so you have to check only these two columns and this question number only. So I am going to scroll now from 5 to 6 to 11. So children, if you are happy, I think you are happy, because I gave these exercises also. I showed you how to solve the original MCQ problem. So if you are happy, please subscribe my channel, but don't subscribe if you have already subscribed, then it will be cancelled if you subscribe twice. And press the thumb up button to encourage me, and share my link among your friends. So thanks very much for the students who are watching my videos again and again. See you tomorrow. Goodbye.